Okay guys, so today we will be just going through uh, the revision of the day one, whatever the questions we did. So this is just going to be that video. Okay, let's start. So let me first go to the question. Yeah, so here we can see the first question was about the set matrix to 0. The question said was we have a m cross n integer matrix. If an element is 0, set the entire row and column to be 0. So for example, they have quoted it here that if any element in that array is 0, then all the rows for that element and all the columns would be set to 0. So that is the purpose of it. So similarly, we have example 2 quoted here. So 0 is here and here. So what we can do is the first row and the first column and the last column as well will be set to 0. That's what we can see. Okay, so from this question what we had was the first method that we could solve this was to iterate through the matrix, record the location of all the zeros in that matrix, and then for as per those locations like row and column, we will be able to go through the whole matrix again and set those rows and columns to be 0 that we had recorded earlier. Okay, so now for method 2, so the first method will require extra space. We will be using, let's say, an array to store those values. Let's say two arrays, maybe for one for the row and the other one for the column. So that will result in having some extra space. Now if we want to save the space, I think in the question they had said, right? So yeah, instead of having O of m plus n space, try to have it inside that. So for constant space, what we have to do is we have to save those zeros values inside that matrix itself. So what we are going to do here, we can see that we have taken matrix m and n. So here we have taken the length of the matrix row and column, and we have taken one variable called k and set it to 0. So the first row has zeros, we have to check that. So while k is less than n, that is length of the row, and matrix 0 and k, that is the first row, is not equals to 0, then we will increment k. Okay, so what we will this will tell us is that we have how many zeros in the first row. Okay, so now what we did is we iterated through the whole um, matrix from I equals to 1. That means from here, let's say the first like after the first row we started from the next one till the last one, and for for a column we don't have any restrictions, so it started from 0 to the last one. So now we are checking if we are having any value inside this matrix as 0. So let me just show you in the iPad how it looks like. Sorry, let me just give me a second here. Okay, I think now we can see the screen. So just let me go through the question once here. Yeah, so what I was saying is we had that matrix, right? So 0 1 2 0 3 4 5 2. Let's say here we have 0 and 1 1 and 5. Okay, so what we did for the first uh, condition was we checked how many zeros are there in the first row. So we had one element called k that recorded that value. So k is less than n represent a number of rows, and m is for column. So okay, so what we did was we actually counted as number of zeros. So k is less than n, and matrix 0 comma k is not equals to 0. So actually we were counting how many non-zero numbers are there. So let me just have it there. And okay, and we were incrementing k. So k represented non-zero in the first uh, row. Okay, so thereafter what we did was we iterated from I equals to 1 to I is less than m, and we incrementing I. So here we have so we started from here, right? So I equals to this is 0 1 2 3 and 0 1 2. Now this represents a column, and this one rows. So how many columns we have and rows, these are represented here. Now m cross n matrix is this, so number of rows into the number of columns. Yeah, so after this we were iterating from here, j equals to 0 to j is less than n, and we were incrementing j as well. Okay, so here we have I equals to 0 to I equals to m, and j equals to 0 to n. So n represent okay, m is this, okay, and n is this. So that's a bit confusing here now. Okay, fine. So we started from m equals to 1. So we started from here. We are leaving the first row behind, and then we are seeing if we are having any of the values as 0 inside this matrix. So yes, we were having this value as 0. So what we will do, so if we got anything like matrix of I comma j equals to 0, then we will set matrix of 0 comma j equals to matrix of I comma 0 I comma 0 equals to 0. So basically we are setting the first element in the row, and the first element in the column as 0. Okay, so after that what we are going to do is set the 0 having both for the loop or condition, also reversing ith iteration, possibly because we tracked the zeros for the first row before. Okay, so now what we are going to do is we are going to start from I equals to 1 to that, and now we are going to reverse the value, like we will iterate from j equals to n minus 1 to 0, and then we are going to see if we are getting, sorry, let me show it here. Yeah, so what we are doing here is we are going to iterate from I equals to 1 to m and j in the reverse order. So what will happen is if we are getting any value like 0 comma j, that is in the row, in the first row we have any value equals to 0, or we have any value equals to 0 in the column, then we are going to set uh, the matrix of I and j equals to 0. That means all the elements for this iteration will be set to 0. Now we have set all the elements except the first row. Okay, so if k value is less than n, that is number of non-zero elements are less than the length of the first row, then we are going to fill the first row with the value of 0. Okay, so that is the solution that uses constant space, as we are saving all the elements that we encountered in the row and the column. Okay, so let's go to the next question now. That is Pascal's triangle. Okay, so in this question they have said we have an integer num row that returns the number of rows of Pascal triangle. So in Pascal triangle, each number is the sum of the two numbers directly above it as shown. So yeah, we can see in this GIF how we are getting it. So the first element is 1, and then we are adding those elements and getting the sum, and that goes to the next list of in the next array list. Okay, so so if they have given the value of num rows as 5, then we have to print 1 2 3 4 5, these 5 rows. So that's what they in this order. Okay, and equals to 1, then we have to print the first one. Okay, so the solution for this one is pretty straightforward. What we could have done is taken extra space and have the calculation for the next row done as on the basis of the new one, like old one. But we could do this in a constant space as well. So let's say we got the number uh, for which we have to create the Pascal triangle. Now we created a list of integer. That means this is the whole list, and then these are the list elements inside that list. Okay, so that is the final array list that we will be returning. So this is array list, and we have taken previous, uh, that would be the new array list. Okay, so now for we are going through this array. So we add element in the previous, uh, like for I equals to 0 to the number of rows that are required, and we are incrementing it. Now we are going to add uh, array element 1 at the index 0 in the array list of priv. Okay, so what will happen after that, we are going to go from index I to priv dot size -1 and index plus plus. So what will happen in this loop is we will set the index value, that is 1, starting from 1, and we will get the previous dot get index, and we will get the value of the previous index, and we will add both the index values. So for example, we are here at 1 2 1. Okay, so we have already added 1 before it. Now what we are going to do is set the index. We start from 1, so this would be the first index. Now what we are going to do is, now we are going to get the value of that index, like the number value of itself and the index that was next to it, so 1 and 2, and then we are going to set it value to the newest index, that means in the first position. So let me show you in the tab as well how it's going to look like. So let's say we have, okay, we have array list, so initially 1, and let's say after 2-3 iteration we got sorry, one more iteration, we will get 1 to 1. Okay, so what we are going to do in this array list, let's say this is now prev. Now what we are going to do is, we are going to add first element 1 at the index 0, so it will become 1 2 1 1 2 1. Okay, now what we are going to do is, we start a for loop from here to here. Okay, now what we are going to do, we are going to take sum of this and this and put it in the first index, so it will become 3. Okay, and similarly for this one we will do the same, and we take this and we will sum that. Okay, and for the last index we don't have anything, so it will go to like the whole size minus 1, so we won't be calculating this, and it will become as it is. So it will go till here n minus 1 basically. Okay, so the new matrix will become 1 3 1, that is the required one. Now to add all these array list into a whole array list, we are going to do is, we are going to add in the final array list the new array list that we created from prev. Okay, so this prev will be used in the next iteration as well, but this final array list we are adding the new value of prev to this array final list. Okay, and at the last we are just returning the final array list value. Hope that is clear. Okay, then after this let's move on to the next one, that is next permutation. Okay, so next permutation, permutation is of an array of integer is an arrangement of its member into a sequence of linear order. Okay, for example 1 2 3, then a permutation could be 1 1 2 3 1 3 2 3 3 1 2 2 3 1. So next permutation of an array integer is the next lexicographical greater permutation of its integer. Okay, more formally, if all permutation of the array are sorted in one container according to the lexicographical order, then the next permutation of the array is the permutation that follows it in the sorted container. If such arrangement is not possible, the array must be rearranged as the lowest possible order, that is sorted in ascending order. So that is the whole story of next permutation question. Okay, so basically here let's say we have the array nums 1 2 3. So how many permutation it could have is n factorial. So there are n factorial ways to rotate these numbers in an order. Okay, so this will result in 3 factorial, that is 3 into 2 into 1, that is 6. So we will get 6 outcomes out of this. So what will be those? So I'm going to put them in a sorted order as suggested in the question, that is lexicographical. So 1 to 3 is the lowest one because it is in this ascending sorting order. Okay, so the next would be 132. We now after that will be 213, and then it will be 231, and then it will go to 312 and 321, and after this we won't be able to increase it, so it will go back to this. So 1 2 3 4 5 6, we got the 6 permutations of it, and in the lexicographical order. Okay, now what we have to do is we have to find out the way how we are able to do it manually, or how I am able to perceive this, that the next number out of this combination will be this one. Okay, so yeah, let's take an example. So let's take this one, 231 and 312. Okay, so how I knew that after this will be the result. So let's go to this one. Now what I'm doing is, uh, I have to do is a replacement of this value. So basically if I replace this value with a higher value, then I will be able to increase, if we add 1, so that becomes 233, which is greater value than the previous one. So similarly we have to do that, but we have to just use these numbers only. So let's say if we had, any number that is greater than 1, then we would have replaced it with it. So here I think 3 is greater than 1 and 2 is greater than 1. Okay, let's see. 132, or let's start with simple first. 123, right? So 132 is the number. So yeah, sorry, yeah, if we can't find a number that is greater than 1, uh, so if we try to increase this number, right, then we have to replace it with some other number, but we can't find any number smaller than 1 that was in place, right? So we have to like go to the next, that is the tens digit, and see if we have any number that we could swap this with. Okay, so we see that we can't swap it with. Okay, let me think it through. Okay, so we have this, right? So what what we did here was we moved this number, as this number was greater than the other numbers that were here. So we moved this number by a unit place. Okay, so we moved it here and we put it like that. Okay, so if we have any number that is smaller to it, we will switch places with it. Okay, so in this example we didn't had any number that is less than 1. Okay, so that's why we moved to 3. Now we have 2 which is less than 3. Okay, so what we are going to do is we are going to swap these two numbers. Okay, so it becomes 3 2 1. Now to get them in order, we are going to sort these in ascending order. That becomes 3 1 2. So this is the way how we are going to this is the logic that we are going to build in the question itself. Okay, so what is the basic logic here? If let's say this number, now we are going to take this number. So what we are going to do is we are going to replace the unit place or the next one or the next one with the least, sorry, we should not go to the last one. Okay, So if we are going to find a smaller number which is less than the unit place, so if that number does exist in this remaining list, then we are going to swap this number with it. Okay, so we swapped it with this, and what we are going to do next is we are going to the all the indexes that are left to the number that we just swapped, we are going to sort them in ascending order. Okay, so this is already in ascending order, so we don't have to do anything. So let's say now it is being sorted and we have the maximum number that is possible. Okay, so if we are getting any number that is already in descending order, then we will just move it to the ascending order. That is the initial case that was given in the question, that in the lexicographical, if we reach the end, then we have to move back to the first one. Okay, so let's go to the browser and see what exactly is the code that we wrote. Okay, so pivot is the element just before a non-increasing weakly decreasing, okay, suffix. So input pivot is the last index of the number minus 1, index of peak minus 1. So what is index of peak? So sorry, index of last peak. Yeah, so what we did was here that we went through the array, the whole array, in the reverse order, and we found if num minus whatever the index is, like a number just before it, if it is less than the number that was there, so this becomes something like let's go with 231, right? So if we are taking index of last peak, then it is just the number, like if this is I and this is I minus 1, then if I is num of I, or array of I is greater than num of I minus 1, then we are taking the index I with us. Okay, that is the purpose of last index of last peak. So here in this case, I and I minus 1, if I so this is not the case here, we move these two here, the pointers, and then we see that this is the case, then I value is equals to 2, I guess. Oh sorry, it will be index 0 1 2, right? So it will be 1. Okay, so this is what we get from this particular line of code. Okay, now after this, if pivot equals to minus 1, that means we got is uh, nothing. So like index of last peak is equals to 0, then then it will return a minus 1. So if it is minus 1, that means we didn't find anything in this array. Then what we are going to do is we are going to find last index of greater. So it has nums, which was the array, and nums of pivot. The worst case, its suffix is equals to 0. Okay, so let's find last index of greater. So here it is. So what it does is it iterates through the array in reverse order. Okay, and then it takes the threshold that was the pivot value. Okay, and if it is less than nums if that value, threshold value, is less than nums of I, it returns that I, that index. Okay, so int of next prefix, we get this, and we have the swap function. So what it will do, okay, let's clear this one out first. Index of greater. So let's go back to here. Okay, so in this one again, let's find index of last greater. So what we had for this input was nums, that was the array we have, and nums of pivot. So pivot is the value here that I is returned, right, from the index of so it returns the initial, right, index, and that we are going to subtract from 1, so it is I minus 1, that is pivot. Okay, so in this case pivot is equals to 0. Okay, now we find the index, last index of, okay, so it goes through the whole array from here to here, and then it checks if any value in this array is less than the threshold, or greater, sorry, is greater than threshold. So the value here was 2. Now the value that is greater than this is 3, that is here. So it returns the value of index I. So this becomes I equals to 1. Okay, now what we are going to do is swap the whole nums with the pivot and the next prefix. Okay, so what it returns is actually put as the next prefix. Okay, and then what we are going to do is swap them. So swapping them is pretty straightforward. We take a temp variable and then we change the values of those variables. So that means 2 3 1, we take 2 as temp and we give this value as, so this will become 3, and then we take the temp value that was given 2 and replace it here, so that is here, so that becomes 3 2 1. Now what we are going to do is, after the swap we are going to reverse suffix pivot plus 1. Okay, so okay, yeah, let me show you. So this is the function for reverse suffix. So what it will take is nums and the start, sorry, and the start index. So it will reverse the number starting from index till the end. Okay, so basically what we are going to do is going to sort them. So a reverse suffix, so it takes the array and the pivot plus 1. So what our pivot was, our pivot was equals to 0. Sorry, yep, okay, yeah, pivot plus 1 we are going to set. Okay, so pivot plus 1 will become 1. So after the pivot, whatever we have we are going to swap it with. Okay, this is again we are going to swap these things. Basically we are going to sort them. Okay, start is less than end, then we are going to swap nums. Okay, start with end. So we took the end as the last value and start plus plus and end. Okay, that doesn't look good. So basically here I got this one that we are going to put here and here, and we are going to swap these two. But let's say the number was 3 2 4 5 1. Okay, so what would be the next number here in this case? I would say 3. Okay, I think I took the wrong one or what. Right, so 1 2 4 5 and this. Okay, so as per our logic, we will first find the index of last peak, that was we will go from right to left and find what is the value. We will take the set of 2 and see if I minus 1 is less than I. So value of I. So I minus 1 is less than I. So this is the first case that becomes okay. So that's why I was saying let's take more values, right? So put 2 and 1 here, and let's put 3 also here. Okay, so this will become 4 5 3 2 1. So I and I minus 1. So we are taking if I minus 1 is less than I. So I minus 1 less than I, no. I minus 1 less than I, no. I minus 1, yes. So these are the conditions. So after this, what is the value of I that we get? So I value is equals to 0, 1, and then we take that value and subtract with 0. That gives us the index. Okay, so after that we calculate index of last greater. That was uh, what was the condition for that. So we will do the same thing, and this time we take the value of that index and see if we anything is less than that. So basically we take value of 4. 4 is that the value that we have to compare with. So this is the threshold basically. So if anything that is greater than this threshold in num of I, then we will take its index. So we start from here and we see that anything that is greater than this particular value is 5. So we take 5 here. Okay, so the index will be I is equals to 1. Okay, so this is the index of the next suffix. Okay, so now what we are going to do is swap these two elements. Sorry, let me just rename this as next of prefix. Now we are going to swap these two elements, so this becomes 5 4 3 2 1. Now what we are going to do is from pivot plus 1. So pivot was uh, yeah, pivot was 0, or the index was 0. So from 0 to the from 0 plus 1, that is from 1, will start, and till the last we are going to reverse suffix them. So reverse suffix will take uh, num dot length minus 1. So the end value is here. Okay, and start value we are given, and we are going to swap these two. Okay, so we are going to increment the start and decrement the end. So first swap will happen between these two, that is 5 1 4, and we will increment the start, it will come here, the end will come here. So we'll swap them again, so this will start. So yeah, basic sorting is there. So we can either sort them, put them like that, or we could put it like this. Reverse suffix. Okay, basically we are reversing this. It is not sorting, it is reversing. Okay, so after reversing, we whatever we get, that is the value of the next permutation that we want. Okay, so this is something that I should take into consideration next time. So let's mark this question. Okay, so next is cadence algorithm. That was for the subarray. Yeah, maximum subarray we wanted to find. So in the given question, we had one array and find the contiguous subarray that is containing at least one number and which has the largest sum. Okay, return its sum. So from this subarray we need to find that subarray that has the maximum sum. So that is given as 4 minus 1 2 and 1. Okay, and its value is 6. Now how we are going to do that? So if we go through the question, we have so the first way is you iterate through the array multiple times to find all the subarrays and calculate the sum of each one. If it is greater than the last one, then we will update the value of sum and just keep on doing that. So that will take n square time complexity. So after that, what we can do is yeah, that will give you the result, but we have to figure out O of n solution, right? So what what we have here is we were given the array, that is fine. Now we have taken the maximum value as the minimum integer value. So since it will be easy for us to update this maximum, we have taken the minimum least possible value in the integer. Okay, and then we have taken the value of sum. So what we are going to do is we are going to iterate through the array only once. That will result in O of n time complexity, and we are going to take the value of sum. So sum equals to sum plus num of I. So whatever we are getting, we are going to update that. Okay, the maximum sum is less than sum. Okay, if okay, this is the condition. So if maximum sum, that is this one, is less than the value of sum, we are going to update the value of maximum sum with sum, else it will remain max sum. Okay, so after that what we are going to do is we are going to check the value of sum. If that value of sum is less than 0, we are going to set it as 0, and we else we are going to continue with the sum. Okay, so let me show you in here. So let's say 5 4 minus 1 7 and 8. Okay, so we are maintaining two things: max sum, let's put it just max. Okay, and sum. Okay, initially both values, like this is negative integer value. Okay, and this is set to as 0. Now we are going to add that number. The first we are going to iterate to the array and add those numbers, okay, one by one. So plus 5, so the sum value is equals to 5. Okay, now max value is obviously less than some value, so we'll update it. Okay, then after that we are going to again check if this value, some value, is less than 0 or not. So if it is not less than 0, then we don't have to worry. If it's less than 0, then we set it to 0. Okay, now we are going to add next element, that is plus 4. Then it becomes 9. 5 plus 4 9. We update that value, and then we go to the next value, that is minus 1. So that results in 8, and the value is now less than max. So we are not going to update max will remain 9, and we are going to um, update the value of sum if it is less than 0. So it is still greater than 0, so we will take as 8. Okay, so now we iterate through the next element, that is plus 7. So 7 plus 8, that is 15. So we update the value 15, and then we go to the next last one. So plus 8, that results in 23. So that is 23. So the maximum sum is 23, that's we got. And it consists of the whole list of array. Okay, so let's take a different example where we don't take the whole list as a subarray. So minus 3 4 minus 1 2 1 minus 5 4. Okay, max and sum. Okay, now first we take sum as -2. Now the max, yeah, so it was negative integer value. Now that is less than this, so max value is -2 as of now. And then we set the sum value as 0 because it is less than minus, sorry, it is negative number. Then after we add 0 plus 1, that results in 1. So we update the max, it is greater than 1, so we take it. And then we have -3, that results in -2. So we are going to add this, but we are not going to take this as that, so it will return 0. Set some value as 0, then we are going to add 4 again, so that results in 4, so maximum value becomes 4. And then we have -1, so -1 returns 3, 4 minus 1, so 3. Now it is still gonna be 4 because that's the maximum possible value that we got. Oh, sorry, what I did here, this value will be 1, sorry, my bad. Then after this we have -1, then we are going to do 2, so plus 2, that is 5, incremented the value of 5. Now then we have 1 plus 1, that is 6, so 6. And then we have -5, so that is 1, so still value is 6. And then we have 4 plus 4, so value is 5, but we still got 6. So now we have to see where we got 6 for the first time. So this will be the last index of that subarray that we want. Okay, so it was for +1 after 2, so this will be the last number. Okay, now for the first number, right? So if, yeah, so we will see what is the last index where the sum was not equals to 0 for this case. Okay, so it happened it over here where we added 4. Okay, so starting from 4 till the positive number we got. Okay, so that is the whole sub array and the maximum returned sum, and this algorithm is called cadence algorithm. Okay, moving on to the next one. So after this we have sorting zeros, ones and twos. So yeah, given an array nums with an object colored red, white and blue, sort them in place. Okay, so if you want to, okay, it basically means to be in, yeah, which transform input using data structure, however small amount of extra space is allowed. So basically we won't be taking extra space to save those values, and we will be sorting them in place. Okay, so so the object or same color are adjacent with the colors in order red, white and okay, 0, 1, 2. So basically we have to, sort this array, but it should be an in place algorithm. So what we can do is we have this logic here that we take zero count number of zeros, ones and twos, and then as per those number we start placing them in order. Okay, so this won't take any extra space. Now let me try to rephrase this. Yeah, so it said we have to place them in order. So what we did was we took 3 variables. Instead we could have taken an array of value 3. So if there had been like more than these 0 1 2 3 4, whatever the number may be. So what we would have done is taken an array instead of 3 variables, and then what we have done is we would have incremented as we iterate through these. We would increment let's say num of I modulo whatever the number we want, okay, or whatever the number it is. If that value so it could be something like let me show you in the notepad here. So here we have, let's say, array index. Okay, so this would have a maximum size of let's say whatever the array size was, and we will take that size here as well. Okay, now what we are going to do is we are going to set all the elements as 0, okay, initially, and then as we encounter the elements from I equals to 0 to n, then what we are going to do is we are let's say array of I, so this will return the value, so it could be 0 1 or 2, right? So what we are going to do is we are going to take this as an index, okay, and increment that. So let's say we encountered a 1, so what will happen here is we are going to increment this value. So initially it is 0, we incremented it to 1. Now we encountered a 2 and we increment that value. We encountered 1, it incremented to 2. So here we are storing the values and we are seeing how many values are there, and after that what we can do is we could place those values in the next for loop. Okay, so this is the in place algorithm, uh, sorry, in place sorting algorithm. So we can use this. Okay, let's move on to the next one. So stock, buy and sell, this is the next problem. So you are given an array that has prices, okay, so prices is the price goes eh, so prices array is given, and prices is given stock of a day. Okay, so we are given in what this represents is price of a given stock on that particular day. So index I represents days. Okay, so if you want to make the maximum profit by choosing a single day to buy one stock and choose a different day in the future to sell that, so I of sell should be greater than I of buy. Okay, so this is the first condition that we get. So this future is very important and we have to maximize that profit. Okay, so what we can do is again brute force method, go for the two for loops and see what are the values that we could get. So the first for loop could start from I equals to 0 to n, and the next one would start from I plus 1, because we need to see in the future what we are going to sell. Okay, so this is one way. The other way is to go with O of n. So for this we would be needing some extra space, some constant space for that. So here you can see we have profit overall equals to 0 and profit today is equals to 0. Okay, and buy value as maximum value we have. Okay, so after this we are iterating through the whole array and the buy value. So buy value is if it's greater than price of I, then we are going to update the value of price of I, sorry, buy value with the value of price of I. Okay, and if it's not, we are going to keep it the same. So for example we have, let me switch. So for example we have prices given 7 1 5 3 6 4. So this represents day. Okay, so now we are going to go through this array, and we are going to see three values. So profit overall, and buy value, and profit today. Okay, so if that value is greater than the maximum value, so sorry, if its value is less than the maximum value, then we are going to reduce it. So initially this is given as a max integer value, that's why I'm saying if that particular profit, sorry, buy value is less than previous one, sorry, the price I value is less than buy value, then we are going to update the buy value with the price value. Okay, so let's say it's a maximum and we got 7, so we are going to update the buy value as 7, so we are going to buy at day 0. So if what happens if we buy at day 0, so profit today will be price I minus buy. Okay, so profit today, that is price of I, that is 7, minus profit overall. So initially profit overall value is set to 0, so minus 0, that will be 7. Okay, so this is the condition where we are selling as well. So what happens if we sell it today? Okay, so buy value represents the value that we bought it, and today's what happens if we sell today, so that is the value that we got. Okay, so if profit today is greater than the profit overall, okay, so overall it is greater, so we will update the value of profit. Okay, somehow it doesn't fit in, right? Okay, yeah, profit today becomes 0, right? Sorry, my bad. If we buy it today and sell it today, then profit value becomes 0, and that value will not be updated here because it was initially 0. Okay, now let's move on to the next one. And what happens if we buy it today and sell it? So what firstly, are we going to buy it today because its value is less than the initial buy value, so it is very good value to buy it. So yes, we will buy it. And what happens if uh, so profit today, that is today's value minus the profit overall, so profit overall 0, sorry, today's price minus the buy values. So we have taken as 1, that is if we are going to sell it today as well, so it is still 0, still 0, no problem. Let's go to the next day. Value is now 5. So now you see the buy value won't get updated because this is not a good day to buy, as we already had encountered a value that was less than um, today's value in the previous day. So that's why we are not going to update it. But what happens if we sell it today? So today's value minus the buy value, so we get a profit of 4 today, and so that will be the overall profit, or that would be the maximum profit that we are going to get if we sell it today and had bought it yesterday, or the day the value was 1. So that is the value that we got, and then it continues similarly. So 3, so it's still the value is not less than 1, so we won't be updating that. But what happens, we sell it today, then the value will become as 2, which is not less than sorry, which is not more than the profit overall, so that won't be updated. Now we are going to go for 6. Now 6 minus 1, again the value is not less than 1, so it is not a good day to buy, but it is going to be a good day to sell, because 6 minus 1 returns 5, and that results in maximum value update. Okay, so after that we go for 4, but 4 minus 1 is only 3, which is not going to update it. So the maximum profit we could get is 5. Okay, so this is like a basic logic build to buy and sell, okay, and get the maximum value. Okay, so that is all for the day 1 revision. As you can see, I have gone through these only as of now. So on the day 2 we are going to start on uh, these questions, and I will try to update on like a regular basis whatever I could. Okay, so yeah, that's all for today. Thanks for watching. See you in the next one. Bye.